question is, prove that there is no natural number for which 4 power n ends with the digit 0. That means what they are asking us is to show that there is no natural number for which 4 power of 1, 4 power of 2, 4 power of 3 and so on will end in 0. That is, what do you get by this number 0? What numbers end in 0? Do you think 10? 10 ends in 0, 20, 30, 100, 900, 1000 and so on. All these numbers, they end in 0. So what is the factors that you see? For example, 10 is 5 into 2, 20 is 5 into 2 square, 30 is 5 into 2 into 3 and so on. When you see all these numbers that end in 0, you can see that 5 is the common factor across, right? So 5 into 2 square, 5 into 2 cube and so on. Whatever you take, a number ending with 0 should have 1 5 and 1 2 at least, right? We know that 4 power of n can be written as 2 square whole power of n, that is 2 power of 2n. That means 4 power of 1 is 4, 4 power of 2 is what? 16, 4 power of 3 is 64, 4 power of 4 is what? 256 and so on. No matter how many times you raise the power 4, it will not end in 0. Why? Because when you prime factorize 4, you are getting 2 square. That means 2 is the only prime factor when you simplify 4 further. So there is no other prime factor in 4 power of n except 2. That means we don't have 5 in the prime factorization of 4 power of n in short. That is the reason why we can say that there is no natural number for which 4 power of n will end in 0, simply because there is no prime factor 5 in there, right? There is only 2 as the prime factor. This is how you prove this statement. Okay, in the similar way, if I ask you to prove 12 power of n, that means if, for example, I have 12 power of n here and not 4 power of n. This is the same question. I ask you to prove whether 12 power of n ends with 0 or not. How do you do that? How do you write 12 power of n? Can we write 4 into 3 whole power of n? And can we write 2 square whole power of n into 3 power of n? That is 2 to the power of 2n into 3 to the power of n. This is what you get after you simplify 12 power of n to its least prime factors. Right? So, when 12 power of n is simplified to its prime factors like this as 2 power of 2n and 3 power of n, can you see the existence of the prime factor 5 in here? No. That means 12 power of n only has 2 or 3 as prime factors and the combinations of 2 and 3, that is 2 raised to the powers and 3 raised to the power n. But it does not have the number 5 for it to be ending with 0. Right. So that is the reason why we can also conclude that there is no natural number for which 12 power of n ends with 0, simply because there is no existence of the number 5. Okay, there is no existence of the number 5 in its prime factorization. Okay, next problem is to find the last digit of 6 power of 100. Before we tackle the power of 100, let's see what will happen if you raise 6 to the power of 1. You will get 6. What will happen if you raise 6 to the power of 2? You will get 36. What will happen if you raise 6 to the power of 3? you'll get 216. What will happen if you're at 6 to the power of 4? You get how much? 6 are 36, 9, 1296 and so on. So if you observe the trend here, first 6 to the power of 1 leaves you the unit digit as 6, 6 square leaves you the unit digit as 6, 6 cube leaves you the unit digit as 6, 6 power of 4 also 6. So no matter how many times you increase the power of 6, you will get the end result as 6 only. The unit digit of 6 to the power of n can be any number, is 6. Here they have asked unit digits of 6 to the power of 100. How do you write 100? 6 power of 4 whole power of 25, right? So 6 power of 4 will leave the end digit as 6 only. Again, if you take 6 to the 25 also, it will leave you the end digit as 6 only. So 6 power of 4 whole power of 6, and again this will also leave you the end digit as 6 only, and 6 power of 7 also will leave you the end digit as 6. What I have done here is I have simplified 100 to 4 power of 25. 25 again I have written as 4 into 6 into 6. Again I have written it as 6 power of 6. How I have taken 6 power of 4 as 6? Because you know for a fact that 1296 whole power of 25, 6 power of 4, 1296. The unit digit is 6 only here. So no matter how many times you add that to the power, you will get 6 only as the result. Hence, we can conclude that 6 power of n, the unit digit is always 6. For that matter, in this case, n is 100. 6 is only the units digit or the last digit. So therefore, the last digit of 6 power of 100 is 6. Okay, the last problem. Explain why this and this are composite numbers. Let's tackle one at a time. First one, let's say 7 into 11 into 13 plus 13. How do you write this? Can I take 13 as common? Right, because 13 is here, 13 is here. And can I write it as 7 into 11 plus 1? This is nothing but how much? 13 into 78. How? Because 7 into 11 is 77 plus 1. This will give you 13 78. How do you write 78? 13 into 6, right? And can I write this as 13 square into 2 into 3? So, can you say this number in this entire number as composite now? Yes, it is composite because there are more than 2 factors. In short, there is a combination of prime factors when you simplify this here. That is, you are getting 13 square, 2 and 3. So this entire number is a composite numbers because there is a combination of prime factors apart from the number itself and 1. Okay, now what is the second problem in the same way? 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Here also take 5 as common. How much do you get? 7 into 6 into 4 into 2 into 1 will be leaving. That's it. So how much you get? 5 into 42 into 24 plus 1. Okay, because I have multiplied this 42, 24 plus 1. So even though if you multiply and add, here we are getting 5 into some number. Here itself the number is a composite number. So but for the purpose of this problem, let's multiply. What is 40 to 24 is our 16, 4, 20, 1008. So you get 5 into 1008 plus 1. That is 5 into 1009. You get this as 5045. So how did I multiply this quickly? I have made a video, a shortcut to multiply 2 numbers very quickly. I will link it up here. You can watch that. But if you see here, we have got the result as 5 into 1009. Right. So hence you can say that this is also a composite number. End result is 5 into 1009. That means these are the factors of this number. So, can we not conclude that this is composite? Yes, because we have multiplied two prime factors apart from one and itself in here. Hence, this is the composite number. Hope you understood today's video. If you like my video, I request you to please like, share and subscribe to my channel and ring the bell notification down below so that you will never miss an update from me. So if you have any questions, please feel free to comment down below and also drop me an email at the email address placed on the screen. So I will see you all in my next video. Until then, I hope you have a safe day and a wonderful week ahead. Bye.